Good evening. In this very special program, we're going to talk about something that won't happen again for over 100 years, so make the most of it. And this is a transit of Venus. As we know, there are two planets closer to the Sun than we are, Mercury and Venus. And when they pass in transit, you see them pass across the Sun as black spots. Now, the great astronomer Copernicus realized that the planets go around the Sun. What he didn't know was how far away they were. And what astronomers wanted to do was to measure the distance between the Earth and the Sun. And that was far from easy. They had to wait for a transit of Venus. And to see the last one, you couldn't see it well from here. You could from the Arctic island of Svalbard. And that's where 3 of our Sky at Night team went. So, over to Chris in Svalbard.
The archipelago of Svalbard is a starkly glamorous part of the Arctic Circle, 78 degrees north of the equator. Home to eider ducks, polar bears and the town of Longyearbyen, it's a magical place. In winter, the sun never rises here, but right now, in summer, the sun never sets. This is the land of the midnight sun, which is just as well because we'll need that to see the whole transit. It begins just after midnight local time. The weather's not too bad for this part of the world, and I really hope it stays clear because the next transit doesn't happen until the 22nd century, so this is really my last chance. I've never been this far north before. Svalbard is, after all, not that far from the North Pole, and it's already been quite an adventure getting here. The sun remains at the same height above the horizon throughout the day, an effect that feels distinctly disorientating to those of us from more southerly climes. Lucy Green and Pete Lawrence have joined me on this quest. It's the night before the transit, and we're going on a voyage with a team of European scientists who work on the Venus Express mission. Venus Express has spent the last 6 years studying Earth's evil twin, trying to work out why Venus is quite so different from our own world. Amongst those trying to solve its mysteries is Colin Wilson, who helped set up this extraordinary trip.
What's happening tomorrow is that Venus is going to pass directly in front of the Sun, and this is an incredibly rare event. It happens, the last one happened in 2004. The next one after this isn't going to happen until 2117. And also to illustrate how rare it is, the last ones before that weren't since the 19th century.
It seems each generation of astronomers lucky enough to see a transit has their own reasons for observing it. For us, in the 21st century, it's a chance to test methods we might use to study the atmospheres of planets which orbit other stars.
Planetary transits are the only way we have of characterizing exoplanets. These are planets discovered around other stars, of which we've discovered hundreds in the last decade.
We've discovered them because, in some cases, because they go in front of their star.
Because of the transits. But then once we know the planets are there, these exoplanets, we try to characterize them. We try to say, does it have water? Does it have oxygen? Could it be conceivably a nice place to live, or someone may already live? And to study that, the only technique we have is planetary transits. Here we have a very rare event, which is a transit of an Earth-like planet in front of a Sun-like star. And once we've done that analysis, we can actually look up the right answers, because satellites like Venus Express are giving us the detailed composition, and we can tell whether the transit analysis has been right.
Colin and his colleagues may be here for astronomical reasons, but the boat trip's also a chance to see the magnificent scenery of Svalbard and even spot some wildlife.
There he is. Oi.
Well, it's a beautiful evening up in Svalbard, a beautiful location. What do you reckon, Lucy? Not a bad place for a transit.
This is absolutely perfect. We've got fantastic clear skies at the moment, which bodes well. And you know, it was quite a journey getting here, so I'm full of excitement, and I can't wait to see how the sun looks in terms of the sunspots, as well as seeing the black disk of Venus moving across as well.
Yeah, and of course we're here because we need to see the sun just after midnight.
The sun is up for the entire day and all night.
Yeah, it's 7:30 at night and the sun's still up there. It's pretty nice, and it sinks to about 10 degrees above the horizon.
That's right.
Pete, you've been doing some careful observation of the conditions. What did you make of your day here so far?
Well, in the morning I was actually quite depressed about things because there was thick cloud everywhere and there was no wind, so nothing was moving. But then suddenly, as if by magic, it just disappeared completely. So I got the telescope out, tested the telescope, and I actually managed to find Venus, which is really close to the sun at the moment. We're not very many hours before the transit, and I now feel at home.
We also have to worry about seeing, about how crisp the sky is.
I really wouldn't worry about that because the seeing this afternoon was amazing. Venus was absolutely crisp. The atmosphere looks really, really steady. So long as the clouds stay away, and we've got no guarantee of that, but fingers crossed they do, we should have a fantastic view.
So we're looking forward to the transit. You're looking forward to your sunspots.
Yep.
You've got some work to do before the transit, Pete. You've got some images you want to get before Venus hits the sun.
I'd really like to try and get Venus about 1.5 degrees away from the sun, which is really, really close. That's probably about 24, 30 hours before the transit actually starts. And if I hit it right, what happens is where Venus looks like a crescent early at a number of
There's a crescent
days,
when it's further round, and then as it gets closer
as
to
it
the
gets
sun,
closer, the cusps of the crescent start to elongate round, and if you get it at the right point, which is dangerously close to the sun, those cusps join up and you get a ring, which I'm really looking forward to seeing.
This is light being refracted in the atmosphere of Venus.
I believe it's scattered around the
Scattered
upper
around.
part of the atmosphere, yeah, and it's just creating this amazing ring effect.
Well, I'm looking forward to it. I think for tonight I'm going to enjoy the boat trip, see a bit of Svalbard and our surroundings, and if the weather's like this tomorrow, then I will be deeply, deeply happy.
I think I'll be happy too.
We're not the first to travel for a transit of Venus. Previous generations have scrambled to the far ends of the globe whenever these rare events come round.
So we've just come to a grinding halt. We've hit some ice. Feels appropriate actually given the hardships and the struggles that the previous transit expeditions went through.
Our boat journey comes to an end exactly 24 hours before the transit, with brilliantly clear, midnight sunlit skies making Longyearbyen look rather tranquil. I feel rather less calm, it has to be said. We need these clear skies to last until tomorrow. This will be only the 7th transit of Venus ever observed, and the reason transits are so rare is down to a little bit of celestial mechanics. To get a transit, we need the Sun, Venus and Earth to be exactly in a straight line. But that doesn't happen every day. It needs a special set of circumstances.
The solar system is dynamic, and Venus, being much closer to the Sun than the Earth is, orbits more rapidly, taking only 225 days to do one lap.
Whereas I, over here for the Earth, take, of course, a whole year to go round.
In fact, I only catch up with the Earth after 584 days.
And you'd think that there'd be a transit every 584 days. But that's not actually what happens.
When we look at the orbits of Venus and the Earth, we see that they're tilted with respect to each other by just over 3 degrees. And that means that even when this alignment happens, sometimes Venus passes underneath the Sun from the Earth's perspective, and at other times it's moving above the Sun from the Earth's perspective. And in that case, a transit doesn't happen.
So all of this only comes together very, very rarely. In fact, it happens twice, 8 years apart, separated by a gap of more than a century. So that's why we have to wait so long for the next transit of Venus. By the 18th century, astronomers were making incredible efforts to chase transits of Venus. Their aim was to get observations of the transit from all over the world. One famous expedition was led by Captain Cook, and they observed the transit from Tahiti in 1769 before they ran into Australia on their way home. By timing how long it took for the planet Venus to pass in front of the Sun, astronomers realized they could measure the Sun's distance from the Earth. Observing the transit was therefore a high scientific priority. But once mixed in with efforts to improve navigation, it also became a matter of national prestige, as scientists persuaded governments and navies to lend them a hand, as well as plenty of funding. Lucy and I took a trip up the hill overlooking Longyearbyen to talk about the successes and the failures of previous transit expeditions.
Chris, I feel like we've had quite a trek coming up here to be on this beautiful mountain, but really it's nothing compared to the lengths that the previous transit expeditions went to.
Well, actually, I think we've done pretty well. We've come all the way up to the Arctic, but you're quite right, of course, particularly the 18th century transits, when they were trying to use the transit of Venus to measure the solar system. And they sent observers right across northern Europe to try and get as many observations as possible. So, for example, the Swedish Academy of Sciences sent people up to northern Sweden. The French Academy of Sciences, who were behind a lot of the efforts to try and coordinate these observations, sent somebody off to the Russian Siberian wastes, and he had a particularly terrible time because it was spring and he was trying to get to his observing site as everything melted. And of course that's not very good if you're travelling by sled. And so he ended up having to get his local crew drunk to get them to go across the last of the rivers with the ice cracking underneath them. But he made it, and so we have observations from Siberia, we have observations from northern Sweden. What we don't have, and we really needed, were observations from India. And in particular, there was a poor Frenchman called Le Gentil.
The unluckiest astronomer of all time.
He is. He set off in 1760 to see the 1761 transit. He gets attacked by the British.
The world was at war at that point. It was the 7 Years' War.
They only escape because of fog. He makes it to Madagascar. Doesn't make it to Pondicherry, the French colony in India, because of the war. In fact, the British have taken it. And so he ends up observing the transit of Venus from the deck of a ship, really rather poorly.
Which, of course, would be moving all the time.
Exactly. No good for precision observations. But also, they need to know where on the Earth they are. And he can't get good measurements as to where this ship is. And so he decides, quite sensibly, that instead of going all the way back to France, he's going to hang around for the 1769 transit.
So he waited for 8 years, which, you know, when you've gone to those lengths, I suppose you might as well do.
The whole month before the transit was beautifully clear. Gets up every morning and it's clear skies. And then on the morning of the transit, he writes in his journal that he woke up about 2 in the morning. He could hear the wind whipping in off the sea, and he knew that that meant clear weather. But, as you know, he wandered outside, looked up, and it was completely overcast. And he comes back and he describes throwing himself face down onto the bed. And he writes, "Such is the fate of astronomers." And in fact, he went mad.
It is amazing to think that at the time when we didn't know the size of the solar system, we also didn't understand the Earth. We didn't have a map of the landmass and even know how to get accurate positions on the Earth.
They did get observations, particularly 1769, from all over the place. It turns out one of the limiting factors that stopped them getting a perfect measurement was the fact they didn't know the distance between Greenwich and Paris, because some observers reported where they were relative to Paris, some relative to Greenwich, and that fundamental measurement wasn't made till much later.
Yeah, of course, you needed to know the separation to put that into the calculation for the Sun-Earth distance.
Yeah, absolutely. Without that, then all of this effort, all of this trekking around the world is wasted.
And then there's also the other thing that affected them, which is this black drop effect.
Oh yeah, the problems of the
that's
transit
right,
itself.
this elongation of Venus when it's inside the Sun, which means making the measurements, the crucial timing measurement, is incredibly difficult. And we know from Halley that you need to get a measurement to within about 1 second of time in accuracy to get a good Sun-Earth distance.
I think the really interesting thing is if you took what we know about the Earth now, we know the distance between Greenwich and Paris, and we know where the observers were. If you take the measurements they made and that knowledge, you get a pretty good value for the distance to the Sun.
That's right. The best ones were within 1% of what we know as the Sun-Earth distance
pretty
now,
good
which
going.
is incredible. That's right. This is only the 7th transit to be witnessed by humanity, and we've come so far from working out the size of the solar system to looking for life elsewhere in our universe.
Well, first of all, let's hope we see it. Well, I'm beginning to understand just how Le Gentil must have felt, because the clouds have rolled in. The sun is now completely obscured, leaving us more than a little worried about the forecast for tomorrow's transit. Inspired by the plucky astronomers of the 18th and 19th centuries, we can do nothing but grit our teeth and hope for the best. Well, while we wait for the skies to clear, we set up our very own transit up here in the snow. And transits occur whenever there are 3 bodies in a row. So we've got the Earth, we've got a purple ping pong ball pretending to be Venus, and then of course we've got the Sun back here. But what you see during a transit depends on exactly where you are.
The observers on the Earth experience an effect known as parallax, which means that observers near the North Pole see Venus in one position against the disk of the Sun, but you'll notice that towards the south, Venus appears in a different place against the face of the Sun.
And so with that measurement, they only needed to know one more thing. They needed to know the relative distance from the Sun out here to Venus, and then from Venus back to the Earth.
And that's something that had been known since the 1600s, thanks to the work of Kepler, who realised that the orbits of the planets around the Sun had a special relationship to how far each planet was from the Sun.
And so that was it. With those two measurements, the speed the planets were moving and the observations of the transits, the observers were able to set out the scale of the solar system for the very first time. There are only two planets which transit the Sun as seen from Earth, Venus and Mercury. Let's go back to Patrick to hear more about these two enigmatic worlds.
Time now to talk about the inner solar system. With me are Chris North and Paul Abel. Well, these planets are very different, so let's begin with little Mercury.
Yes, I have it here, the usual sky at night model.
Yes.
Here we are.
Yes.
Wonderful little Mercury. In fact, Mercury, one of the ancient planets known since antiquity. Our earliest cavemen must have seen it whizzing around in the sky. We had to wait till the start of the telescopic era before we could begin making any investigations of it. And even then, we didn't see an awful lot.
Well, they didn't really know much till the space age.
Well, that's right. The reason being, of course, Mercury is very small and it's very close to the Sun, and this makes it very difficult to observe. Schiaparelli, of course, made lots of observations of it. We had to wait until, was it Mariner 10 that got out to Mercury first?
Yes, so Mariner 10 went round, passed it by in the 1970s, made the first observations. One of the problems with Mercury is that it's so close to the Sun that if we send a spacecraft there from Earth, it's a third of the distance from the Sun, and as the spacecraft goes inwards, it gets faster and faster and faster, which means that it whizzes past Mercury. So the biggest problem with going to orbit around Mercury is actually slowing down enough.
Yes.
So the Messenger spacecraft had a very convoluted journey to actually end up going into orbit around Mercury, and is the first spacecraft to ever go into orbit. Everything else, Mariner 10, just passed straight by.
So, up next then, the planet Venus. Now, this is a interesting world. It couldn't be more farther removed from Mercury. Shrouded with a very thick, poisonous atmosphere. A lovely bright object.
Planet of beauty. Go there and you'll find anything beautiful.
Well, indeed, yes. It's more like hell. It's an interesting planet for observers to look at. It's very, very bright. And the reason it's very, very bright is because the vast clouds covering it reflect a lot of sunlight. And this means that the early telescopic observers that looked at Venus didn't see an awful lot. So Venus became a mystery, and we had to wait till the spacecraft got there, because there was very little we could do.
With the space age, we've had probes that have actually gone to Venus.
Simply the earlier probes were squashed on the way down.
They were,
yes,
they
so-
didn't make it to the surface.
The pressure on the surface of Venus is 90 times the pressure on the surface of Earth. So they had to go and build their spacecraft again to try and survive the pressures, and they got to the surface and discovered the temperature on the surface is 400 degrees. The longest a probe has survived on the surface was Venera 13 in the 1980s, I think. So
And that's about that lovely image. It's one of my favourite ones, a little bit of glowing sky.
So that lasted for 127 minutes. That's just over 2 hours before finally its electronics overheated.
I think we can forgive it for that.
Well, yes. I wouldn't like to survive in that kind of environment.
No,
But
no.
to make it worse, the atmosphere is very dense, the surface is very hot, and you have sulfuric acid clouds to contend with. We've had probes go there. So we had the Magellan probe in the 1990, which made a radar map, so using radar that can penetrate the very, very thick clouds. And was able to map the surface and show us mountains, volcanoes in fact, possibly or probably not active, certainly not very many of them active, and valleys and so on, and lava flows.
There's very interesting structures on the surface as well, like those sort of pancake shapes. Very, very weird surface.
All kinds of volcanoes.
Yes, it's a very volatile world on the surface to look at, and it helps that the maps are always drawn in that sort of orangey yellow colour, which makes it look very hot.
Whether any of the volcanoes are active now, well, that's a matter of debate.
A great debate.
It is. We know that a few 100 million years ago there was an enormous resurfacing of the surface of the planet due to this immense bout of volcanism which plagued the surface, and it's possible that Venus undergoes such bouts, in periodic cycles.
It would certainly explain why the surface appears to be all the same age.
So the surface is all the same age and actually all very young. If we try and count the craters on the surface of Venus, then we actually see there's very few. There's only about 1,000 on the entire surface, and over a whole planet, that's not very many at all. Partly that's because it's been resurfaced, and partly because the atmosphere burns up the smaller objects that hit it.
Both Mercury and Venus are inferior planets. They are closer to the Sun than we are, and from our point of view, occasionally they pass in front of the Sun in an event known as a transit.
The best place to study the Sun is in fact from the very northern climes of Europe in Svalbard. And the team, Chris, Lucy and Pete, have been there.
So back now to Svalbard.
The Sky at Night team has come to the Arctic Circle to see the transit of Venus, which is happening later tonight. Down in Longyearbyen, Pete has been on an expedition to find a good spot to observe the Sun and get an elusive shot of Venus as it approaches it.
Well, I brought lots and lots of kit over from the UK to see the transit of Venus from Svalbard. Now, the transit is going to occur in a number of hours' time, but before that actually happens, there are other things to look at. I've been following Venus over the last few days from the UK and watching that beautiful slender crescent get thinner and thinner and thinner. Now, as it gets really close to the Sun, the cusps of the crescent begin to extend around, and if I'm really lucky and if I can find it today, I might be able to see them join up to create a ring, which is the atmosphere of Venus. Now, that should be really quite special, so I'm really very excited about that.
Venus guards its secrets well. In a telescope, it looks so lovely, mysterious and welcoming. But its thick, impenetrable atmosphere is full of carbon dioxide and sulfuric acid, a most uninviting world. Venus and Earth are almost the same size, but that's where the similarities end. It rotates much more slowly and spins backwards. It also lacks a magnetic field. Earth's magnetic field protects us from damaging particles from the Sun and space, and a nice bonus is the aurora borealis. In winter, Svalbard is a great place to see the northern lights. It's a sign that the magnetic field above is acting as our shield.
What I have here is a magnet with a north magnetic pole and a south magnetic pole and iron filings around the magnet. So if you look carefully, you can see that the iron filings take on what is actually the shape of the magnetic field, and they form these beautiful arches going from one pole to the other.
That's right, you can see here, so they're in arcs, right? So this is a pretty good model of the Earth's magnetic field.
That's right, and it's nice because this is three-dimensional, so you can see the magnetic field forms this sphere, and the magnetic field lines shown by the iron filings go in at the North Pole and the South Pole, which is what we have happening around us here for the huge Earth's magnetic field.
So if this is inside the Earth, we're down here in this cluster of iron filings at the top, near the poles.
That's right. So this is the shape of the Earth's magnetic field sitting in the solar system.
And so when you have the solar wind, those particles coming in towards this, they get channeled down towards the poles. That's why we get the northern lights.
That's right, and it becomes very clear to see why that's the case. So the particles coming from the Sun can get onto the Earth's magnetic field lines, and if they do that, then they can be funneled down, and they naturally get funneled to the polar regions because that's where the magnetic field is guiding them. The field acts as this kind of tube along which the particles can flow. So here on the Earth, this invisible magnetic field above our heads protects us from the solar wind, and that's a really important thing. But on Venus, there's no protection at all.
Without a magnetic field, Venus has no way to stop the solar wind from constantly bombarding it, stripping away its atmosphere. We think that billions of years ago, Venus was once a wet world, and Dr. Janet Luhman talked to me about why she thinks the lovely Venus became the Earth's evil twin.
And now look at it. Well, Venus is special in that, and different than the Earth, in that it doesn't have an internal magnetic field. And so there is nothing to prevent the solar wind from directly entering the upper atmosphere over the whole day side. Slams straight into it like a comet. And very long time ago, science fiction writers thought Venus was a very large comet and presented it as such. When we finally visited Venus with spacecraft and took detailed measurements, we of course prove to ourselves once and for all that Venus is very much a planet. And one of the things that's been a puzzle is the lack of water on Venus and what happened to it in the past.
So assuming that Venus began in a very similar state to the Earth.
Exactly. Whereas Earth in its oceans has the order of a kilometer equivalent of water if you spread the oceans over the globe. At Venus, there's only a few microns of water in the atmosphere. And so that and the particular composition of hydrogen in Venus's atmosphere, which is unusual, combined with the oxygen loss that we see, suggests that maybe water has been stripped off of the top of the atmosphere over the 4.5 billion year lifetime of the solar system. The main question is whether it occurred in a much stronger fashion early in the solar system's history.
It feels like Venus has been overlooked in recent years. It's become the evil twin or the ugly sister, but actually there's still a lot of exciting things to find out.
Exactly, and in fact it is the twin Earth from early observations of its similarity in size, and it is the most proximate planet, it's closest to us. And yet all our attention has been focused on Mars, in part because we can actually go to Mars and rove on the surface and photograph it in minute detail in all wavelengths, essentially. At Venus, we have this shrouded body with incredible pressures on the surface that would crush most equipment and, of course, be totally unfriendly and inhospitable to anything resembling life as we know it. And now it's good to see that there's some attention being refocused on Venus.
In space, the LASCO telescope is looking at the sun, and we can see Venus marching towards its edge. Just as it was getting dangerously close, Pete did manage to get his Venusian ring created by sunlight being deflected off the top of the atmosphere. It's really rather beautiful.
It's 11 o'clock at night here in Svalbard. The Transit of Venus festivities have begun. It's still light, as you can see, which is great. It's also pretty cloudy, which isn't. There are a few breaks in the clouds, though, so we haven't given up hope yet. But whatever happens, in about an hour from now, the last Transit Venus of the 21st century will have begun, whether we're able to see it or not. Most of Svalbard is here, and the locals are getting into the spirit of the occasion. The longer we're here, the more I begin to sense what life in this frontier land must be like. Well, previous explorers who've travelled to see the Transit Venus found all sorts of things, so pretty much imagine this is what those Arctic explorers encountered back in the 18th century.
What I have here is the low-tech way of watching the transit of Venus. So this is a simple solar viewer. The light comes in through the glass at the front, bounces off some mirrors on the inside, and then down through a lens. And actually it projects an image of the sun a few inches across on the piece of paper in here. So this is a really simple and really safe way to look at the transit of Venus, and I should be able to see the event happening really clearly with this piece of kit. But also using this, I can see sunspots that are on the surface of the sun, and I know at the moment there are some really fantastic sunspot groups, so I'm looking forward to seeing just how close Venus gets to those.
The skies are still ominously heavy, but Miguel and Michelle from the European Space Agency have set up their telescopes nonetheless. They'll be sending images of the transit live onto the web, but only if those clouds clear. Also here are the Venus Twilight Experiment, a global collaboration in the best tradition of transit hunting, with teams in Japan, in Hawaii, in Kazakhstan, and even in Ulaanbaatar in Mongolia. All of these teams are waiting to catch something called the arc of Venus, or more scientifically, the aureole. It occurs when the sun's light is seen shining directly through the thick Venusian atmosphere, rather than being reflected by it. And it occurs for just a few fleeting seconds around the beginning and the end of the transit.
There will be sort of a ring of light around Venus, which is fantastic actually to see, and we have great expectations on how beautiful this should be. It's mostly visible during what we call the first contact, which is when Venus hits the Sun, and the second contact when Venus is now fully plunged into the face of the Sun. So it's a matter of 15 to 20 minutes.
The arc of Venus was seen during the 2004 transit, both from the TRACE spacecraft and by amateur astronomers on the ground. Remarkably, we can even see detail in the arc, revealing the layers of Venus's atmosphere.
In 1882 there were only visual and some photographies, but the photographies didn't see the aureola. Only drawings by expert observers mentioned this aureola, as it was also mentioned in the 18th century events in 1761 and 1769.
The telescope works by blocking out the sun so that the delicate arc of light can be revealed, but setting it up in Svalbard has been tricky.
We wanted to observe from here because this is the only part of Europe that can actually see both ends of the transit. The ingress, what we call the ingress, which is when Venus comes into the Sun, and the egress, which is the opposite. And for that we had to use portable equipment because there is no major astronomical facility here, or fixed facility. And this is also something which is difficult for any astronomer, to align a portable motorized mount. You always need to aim at the pole in a very accurate manner, and this is the midnight sun period of the year, so there are no stars at all, so this is difficult to do.
It's nice to see that the French and the British can set up next to each other without war breaking out. A little bit different from the 18th century, but we do still share some problems with that unluckiest of astronomers, Le Gentil. After all, the thick clouds are still hanging about, and time is beginning to run out. Look, I'm not a natural optimist, but that looks much like it did just before we got that clear patch half an hour ago.
Well, if it does go, it's going to be a real rush, because
I think that's... Do you see what I mean?
sun.
I think that's breaking in between the different bands.
We might just get a crack. That's all we need.
Yeah.
Actually, I don't actually know where the sun is up there at the moment, but if you see those rays in the
I think
distance, they're pointing back to it.
That's right. Really? Has it moved all the way around over
It has, yeah.
It has, yeah.
well, then
We've been waiting a while.
I'm probably wrong, though.
It's so bizarre because we're now, well, obviously coming up to midnight,
Here we go.
and it's daylight.
It is, which is good.
That's what we
For a
want.
transit, that's excellent,
This is
yeah.
the thing, for Transit of Venus Explorers, we're in the right place at the right time
Under
with
the
our
wrong
equipment. Well, we can't control the weather.
We can't control the weather.
The transit will be a long affair, lasting nearly 7 hours, but the beginning and end are dramatic. The tension is running high. We're getting another glimpse of the sun coming out, but not the full disc. But will it be enough for Pete to get his telescopes lined up? Oh, such a tease.
Well, Lucy, you were telling me yesterday that you wanted to see something called the black drop, which you only see on the way in and out.
That's right. So this elongation of the disk of Venus when it's close to the edge of the sun, and actually since the last transit, people have put forward an explanation for why that happens. So I want to see it myself, and then later on see other people's opinions.
The sun's right there, isn't it?
We've got a few minutes to go.
About
Come
6
on.
minutes left.
We've flown all this way. We've bought all this kit.
It could do it, actually. I'm going to change tack.
You're
I'm going to go to
become
white
optimistic.
light now.
Yeah,
Ooh.
okay.
And have a look. I'm going for it.
Go on then, do we need to get out your way, Pete?
No, you're fine there.
Yeah,
I'll just-
Patrick tells a
Getting
story
brighter.
of an eclipse in Finland where he was the only person to leave his kit.
Yes, I know.
And, at the
And he
last
was the only
minute-
one that got the picture.
Yeah.
You've got to be optimistic, haven't you? You just don't know what the cloud's going to do.
No, it's just thin enough to give us a little bit of hope.
Yeah, and this telescope will track the sun.
It will, if I can find the sun
Yeah. So
first.
once we're locked on.
Yeah.
Well, somebody locally predicted it was going to clear, the clouds would clear at midnight.
But also, according to it, they were sitting on their porch with a beer when they predicted that. So
That can make you more optimistic.
this is astronomical torture. Goodness knows how those who'd staked their career on transit observing must have felt. Well, about 2 minutes left. 2 minutes left.
It's not looking good.
It's not. My optimism was there for a second. It's faded
mine
already.
peaked for about 30 seconds and now it's gone.
There's a
yeah.
higher level of cloud that's come in that wasn't there, literally wasn't there half an hour ago.
It's really grey. Really, really grey.
The sun is just there, near that gap in the clouds. And we've got the telescope, so we just need...
Oh, is that the sun's... No, it's not the sun's disk, is it? Is it?
Is it?
That could... No.
No,
It's too
is
far
it?
over. I'll go with anything. I'll go with anything.
Whatever. Yes, it is.
See round.
It is. Is it? Yes, it is.
Yes,
There's
it
the
is.
sun.
Pete, well spotted. 2 minutes to go.
Okay.
This would just be the most magical piece of time. Come on.
Oh my goodness, come on.
It's not bright enough to register through the filter.
A minute and a half
It's about to
go.
brighten, Pete. It's about to brighten.
We've got the top bit as well, which is what we need.
Is that where it is?
Yeah, it comes in across the top. Well, yes.
They're
so
already
from
aligned.
our-
I think some people over there have got it. Literally 20 seconds and the sun's just come out.
just
So
gonna
I think
go
some
with the
people over
camera.
there have got it. We've heard some gas. We can see the sun. Can Pete get his telescope on it though? That's the question. It's going to disappear again.
Oh, come on.
A clear patch in the right place at the right time, and Pete gets his first shot of the transit of Venus. Pete, I can't quite believe we've got this, and I won't distract you too much, but just at the point where Venus started crossing the sun, we've got a clear patch, and there is the last chance you'll have for 105 years to see Venus beginning to cross the face of the sun.
Even though the clouds are there, it still sort of sends tingles up the back of your neck,
Sort of
actually.
dramatic with the clouds going past, isn't
Yeah,
it?
definitely.
Proof that the solar system is working. There's a sunspot up there in the top
There are
left
loads of
as well.
sunspots on there, which is sort of really quite photogenic. It's like the sun is a canvas against the in which the transit is taking place.
That's very nice.
Yeah, I thought so too.
Yeah.
Venus has begun its long crawl across the sun's disk, a majestic demonstration of the power of celestial mechanics. But we are still at the mercy of nature. So if the clouds weren't here, we should be seeing Venus now just passing over the edge of the sun. We've had first contact, and in a few minutes' time we'll have second contact. So maybe we'll catch that one.
Lucy, we've got it.
It's actually
we're
behind
almost
some
there.
thick cloud.
Right.
It's just about there.
Oh yes, there it
There
is.
it is.
It's moving quite
Wow.
quickly onto the disc, isn't it? It's
It-
maybe
oh,
halfway
incredibly
there
fast.
now.
Yeah.
Wow.
My goodness.
The
So we've
recorder.
got 10 minutes now until second contact.
That's right, when the Venus is
It's
completely
fully inside, that's right. And when we can see if we can see the infamous black drop.
It's very black at the minute.
exist.
Previous observers reported that something strange happens as Venus moves onto the sun's disk. It seems to stretch, forming the infamous black drop. We'll have to wait and see if the black drop is real. For now, I'm with Pete, a skeptic.
It's like if you hold your finger and thumb up and you have them close to you, and as you put them close together, it looks like your finger and thumb
yeah.
begin to join together.
Yeah.
That's
Yeah,
one
even when-
theory.
yeah.
And in
then-
bad optics.
Well, you've
Yeah.
got a little layer of heat
Yeah.
between your finger and thumb, and I think
Yeah.
that just distorts the view slightly.
Everyone is just ecstatic that after our long wait, we're finally getting a glimpse of Venus. These are some of the first views from spacecraft looking at the sun. In these amazing time-lapse movies, we see Venus entering the sun's disk with all its dramatic texture, in breathtaking detail. It's both beautiful and astounding. The transit's officially started now. We can actually see it from Svalbard. Only an hour late, but that's pretty good. Look at
Look
that.
at that, isn't that spectacular? That big black circle.
It's like so
Have
clear.
you seen this? It's got all the ridges in it. It looks
does,
like it looks like an ESA logo.
But you can see the disc really, really clearly. And it looks terrific. It's really clearly defined.
It's touch and go at the minute. One moment the sun's there and then it's gone. But we've still seen it. I think we should settle in for the night, guys, because that's gone behind
definitely.
a very large
Yeah.
bank of cloud. So transit is underway.
We've seen
We
some
saw
of it.
some of it.
Yeah.
So mission accomplished as far as I'm concerned. And now everything else is just gravy. Do you think?
Yeah, definitely, definitely.
Gentlemen, how is it for you? How's it going?
Of course, stressy.
Yeah, stressy,
because nothing, we can do nothing automatically, so we have to do it manually.
Because of the clouds.
Because of the clouds means that we have to adjust the cameras, the setup for every shot.
But you've managed to see something.
Yes, and it's so exciting. We had to take the filter out, in fact, so that we could see the image of the sun through the clouds. So the cloud was the filter.
Looking at the sun is incredibly dangerous, so do always use filters or project its image and be very careful with the telescope. How are you doing so far? Have you seen anything?
Well, yeah, I saw quite a nice view in the beginning for a glimpse of both Sun and Venus, and then we had some clouds, and I swapped the eyepiece to the camera and I made some shots. So I think I got a couple of good things.
So you've seen the transit?
I've seen it, yes, I've seen part of it, yeah.
Mission accomplished.
It's going great. We've got the live feeds from the guys here and also their colleagues in Canberra, which we're keeping an eye
Clear
on.
weather in Canberra by the look of it.
Well,
Some
there's
clouds.
actually some cloud as well, but there's Venus down there.
Excellent.
And I've just taken a nice shot of the transit through our ESA TV cameras.
Very
did a
good.
video camera there as well.
And going straight out on Twitter.
Yeah,
That's
being
something-
retweeted around the world.
You know, that's probably a first. This is live tweeting of a transit for the first time in history.
That's probably
There you
right.
go.
That's
They're
pretty
always
amazing.
firsts.
Yeah.
Some news from the Twilight team. No luck in Svalbard, but they've heard from Arizona that there's been a successful observation of the arc of Venus.
The report I just received says that they observed the auroral very well. It was quite bright, very asymmetrical as expected.
Which is what you wanted, because that's the interest.
And it was more intense near the pole, which is what we want. And moreover, it was also observed well before the first contact.
Ah, great.
Which means we'll have a long photometric curve on each of the points on the Venus atmosphere, and this is what we want, because the longer the curve, the light curve is for each point, the best constraint we have on the temperature at the point we try to measure.
What about Ulaanbaatar? Have you heard from them?
No, but I think they don't have a fast internet there, so I don't expect them to call during the transit.
So we've got the sunspots that we can see really clearly.
Oh, yeah, there they are.
A variety of sizes and a real cluster of them actually. So
There's
Venus,
an enormous number there, aren't there?
Yeah. And actually I can see the umbra and the penumbra of some of those sunspots.
The faint shadow around the sunspot.
That's right.
And then Venus, of course, with no penumbra, just the big black dot moving across the face
Isn't
of the
that a
sun.
fantastic sight there with Venus is
Hey,
just
listen,
so
you should get your
perfect.
soloscope out. It's bright enough
It's actually
now.
bright enough now, I think. Finally, we've got a shadow on here that I can use to align it. Now,
There we go. There we go.
Yes.
There's Venus and 1, 2, 3, 4, 5, 6 sunspots maybe.
fantastic.
What I like about this sunspotter is that because the Earth is rotating so fast, the sun is moving out of the field of view of my sunspotter, so I'm always having to make an adjustment every few minutes.
It'd be much easier if the Earth didn't rotate.
Working out the sun-Earth distance would be much easier as well.
That's true. That's true.
So here we can see Venus looking pretty much like a very large sunspot with no penumbra, with no
That's
light
right. It looks
around the
darker
edge.
than the sunspots, I think. Maybe it's just larger, but
Yeah, much larger. Yeah.
it's great to see it with such a simple, no offence to your sunspotter, but with such a simple device. There we go, that's full sunshine, I reckon.
Yeah.
So let's have a look. Have you seen it with the naked eye yet? Or
No, I
with the
haven't
glasses?
given that a go. Let's give that
Let's
a
see
go.
if we can see this. Oh yeah, there it is, I can see it. That's rather nice, actually. There's a band of cloud that looks rather pretty as
It
well.
does. It's about 1/30th of the width of the sun, and I was worried that my eyes wouldn't be good enough to be able to pick it out, but
There
there
we
it
are.
is.
All we need now is the rest of the clouds to go away. The sun is always changing, and one type of feature that comes and goes is the sunspots. These can be bigger than the Earth, and they're cool areas on the surface. Right now, there's a group of sunspots and also something called a filament, where the sun's magnetic energy is holding up gas.
I'm trying to see Venus with a hydrogen alpha filter. The sun is so bright that of course it makes it difficult to see any detail on your computer screen. But with my patented black shroud, which got a lot of interest from some of the locals yesterday, it helps me to see the detail. But there's the sunspot group, and there is a giant twisting filament, a dark snaking line, if you like, running between all the sunspots above there. So that makes quite a pretty picture.
I study the sun every day using spacecraft that look at it in different ways. Each wavelength tells you something different.
One thing I wanted to ask you, Lucy, was Pete's been imaging in hydrogen alpha, So what exactly is that? What are we seeing in these H-alpha images?
So in hydrogen alpha, this is a narrow part of the visible spectrum that the filter allows through, and it's a really useful part of the spectrum to use because it sees not the lowest part of the sun's atmosphere, which we call the photosphere.
That's the bit we normally see in most of the images.
That's right. So when you see sunspots, it's normally the photosphere that's being imaged, but the hydrogen alpha sees a layer of the atmosphere slightly higher, a layer that we call the chromosphere, and this is the orange or the red layer that you see during a total eclipse.
And what you pick up is all the activity on the sun. So I noticed in one of Pete's images, as Venus moved across, you had some what looked like sort of squiggly lines just above it. Are those the filaments?
That's right. So these are the filaments. These are sort of, they look like snakes on the surface of the sun.
Yeah.
And then when you see them at the edge, we call them prominences.
Oh, they're when they stick out.
That's right, but they're exactly the same thing. So they are relatively cool gas that's held up in the sun's atmosphere a little bit higher, and I was really pleased to see that there's a really nice sort of S-shaped one on the sun at the moment. So there's a dispersed sunspot group that we were looking at in white light.
That's right, yeah.
Yeah,
Saw that.
and then when we moved up and looked in the hydrogen alpha filter, we saw not really the sunspots so much, but we saw the filament that was also in that sunspot group. So then we start to go up into the atmosphere, which is fairly hot. I mean, it goes from 6,000 degrees centigrade at the surface up into millions in the atmosphere, and that's, you're right, that's what we start to see from space. So we start to look in ultraviolet light, extreme ultraviolet light, and then even X-rays coming from the hot atmosphere.
So I know some of the satellites saw the transit before we did, because of course they see the Venus going through the sun's atmosphere before it crosses onto
That's
the
right,
disk.
yeah. So now is a really nice era to have a transit of Venus, because you're making use of the light all across the electromagnetic spectrum. So it's going to be some fantastic images that come through.
It's sort of magical being here and seeing it the old-fashioned way and having the space-based images as well. It's pretty exciting. Colin has an ingenious arrangement with which to view Venus, and it's a safe way to look at the sun by projecting it. The transit's really a rather special sight, even at 3 in the morning.
This is something I borrowed from a colleague, and it does look a bit like a pizza box. It is a bit of folded cardboard. You get quite a good image.
Yeah, you've got the sunspots there and Venus, and it must be about mid-transit, I would say.
Yeah,
maybe
looks about
just
mid-transit.
Just past.
We didn't have this going from the beginning of the transit because we've had clouds, but now it's glorious. In fact,
Yeah,
some clouds.
it's
but
good.
there you go.
So actually, what I meant to ask you while we're sitting here mid-transit is, you're of course involved with Venus Express, which is going around Venus. What's it doing right now, do you think? Will it be making observations during the transit?
Yeah, so it's got a 24-hour orbit, which is convenient, so we know exactly where it is in its orbit. At this time of day, in fact, around 3 in the morning, is usually when it comes to its closest to Venus. It'll be taking some particles and fields measurements, so it's got its magnetometer recording magnetic fields. It could be searching for lightning right now, because we only are sensitive to that when we're within the magnetosheath. That's the magnetic
You're close
field.
in.
Yeah.
See, that's quite something. This is the dot down there that I can see is a planet the size of Earth, and you're telling me there might well be storms going on. It suddenly makes it feel real, right? This transit.
So we've seen the signs of lightning now. I don't think you'll see flashes.
Not even if I look closely in your
look really closely. No.
This transit's fun to watch, but astronomers are using transits to study planets orbiting other stars.
Here we have an extraordinarily rare event. We have a transit of an Earth-like planet in front of a familiar star, and we can use all the transit analysis techniques on it, and we can try to study it. We can look for signs of habitability, and when we've done that analysis, we can see whether we're right, because we know what Venus is like in detail, because we've got a satellite there measuring it in great detail. So if we find that our transit calculations are giving us the right answers, that gives us a lot more confidence in our analysis of exoplanets and our search for Earth-like planets.
Venus is continuing its magnificent journey and is now more than halfway across the sun. Pete has been looking at it with a special telescope. By using filters, he can look at different layers of the sun. Seeing the calcium layer reveals hidden detail.
Pete, you've been observing with the calcium filter. Can I see some of your images?
Yeah, sure. I've sort of taken a whole sequence to try and get the entire disk on here, but with calcium, a calcium filter
So
like this.
This is the telescope that you were using.
Yeah. You see, I sort of describe it like a super white light view. It's like you get a view using a normal white light filter, so you're just looking at the surface of the sun, but it's plus because you see all the bright regions around the sunspots in the centre of the disk, and it's just full of detail. It's absolutely gorgeous.
Let's have a look, because I don't often look at the sun in this wavelength, so I'm familiar with visible light and familiar with the hydrogen alpha, and both of those I'd use in my research. But I'm keen to see how it looks, because again we're looking at the chromosphere of the sun.
Yes,
and
right at the bottom of it, is that right?
Right, so I mean, the emission can come from a variety of heights. And the sunspots appear dark still, so I can see those really clearly.
Yeah, but then you get this sort of, it's a large granular network, that's the chromospheric network.
That's right. So what we're able to see is actually created by magnetic fields. Where the magnetic fields are very strong in the sunspots, you have dark features, which is the same as you have in the visible light. But then this bright mottled structure, that's still formed by the presence of magnetic fields, but just weaker. What's been your favourite wavelength? Visible, calcium or hydrogen alpha?
That's an awful question to ask. I don't know. Once I switch to one, I want to go back to another because they all have their merits. I think the white light looks fantastic, but the calcium, you get all that beautiful detail underneath Venus and moving across the disk. And in H-alpha, you get all those beautiful snaking magnetic features. So my answer to your question is I don't know.
All of
They're
them.
all lovely, yeah.
As well as the transit, I've been enjoying my first experience of the midnight sun. It's weird to think that we've been up all night and it never got dark. Despite the fact, though, that the light hasn't changed, it is morning, and we're all beginning to feel a bit of night shift strain. But it's time to wake up, because the end of the transit is approaching. We're not far off the black drop here, actually. Look, this is Venus getting very close now. This would be the point where you were struggling if you were trying to measure the scale of the solar system. This would be the point, wouldn't it, when you were just trying to time
things very precisely.
Yeah.
It's really wobbling around in the atmosphere.
The atmosphere is
there,
very
isn't it?
poor,
It's
yeah.
really, really poor, but we're just... I think I could still see some...
Gap.
So it's
There you
hard.
go.
That's it.
There you go.
That's
That's
it.
the black drop.
Yes. Ha.
So it looks like a connection between the blackness of space and then,
And that's caused here because we've got such poor atmospheric conditions.
Yeah. That was third contact, so Venus is on its way off the disk of the sun, and there really can't be much transit left.
So right now we are in between the third and fourth contact, and it's really amazing. It's astonishing that we are seeing this.
Yes. We are lucky that the weather is now good for the final phase.
As we reach the end of the transit, with Venus just about to move off the face of the sun, a reverential quietness has descended on Svalbard.
A few minutes to go.
Yeah, 3 minutes by my watch. Yeah. That's good enough.
Yeah, then it will rotate across. That's nice.
You can just see it here, so just as we come up to fourth contact, it's just visible with Venus on the edge of the sun's limber. It's really going, isn't it?
Yeah.
Even without the black drop, you're on this, if this is what you were using to make your measurements, say, in the 17th century, has it gone, has it not? It's coming and going because of the atmosphere.
That's right. If you don't have really good conditions, this becomes even harder.
That's right.
Oh, goodbye, Venus.
Miguel and Michelle cast their laptops aside to see those final moments through the telescope, just as their predecessors did centuries ago.
It's gone.
Yeah. Quick, record the time. Record the time.
It's gone.
So we think that's it. After hours of waiting for the skies to clear and then hours of watching Venus move very, very slowly across the disk, looking at the sun in different wavelength bands, seeing the sunspots, the filaments. It looks like Venus has finally gone from the face of the sun.
It's rather depressing.
I'm going to bed.
You've been working hard, Pete, seriously. Venus has departed, the show is over, so let's see how everyone else got on. Well, Colin, it's all done. How was it?
It was good, and bits of it were even sunny.
Yeah, especially the end. Did you see third and fourth contact then?
Yes. Looking over various shoulders and trying to goad people into telling me exactly when they occurred. It was great fun. And
it's really difficult, isn't it, to judge that final? No wonder their timings were difficult. I found judging that third or fourth contact was really hard.
Yeah, we had a couple of people looking through very similar equipment, and they disagreed by several, maybe 10 seconds, something like this, or more. Whereas meanwhile, an observer on a different telescope was claiming 20 seconds out. So
well, I heard you say we were over there, and I heard you say, has anyone seen fourth contact? And we thought it was 30 seconds earlier, so we were ahead of you.
See, if we were the set of observers who'd been sent out by the Royal Astronomy Society, we would have done...
We'd be scrapping on the way home.
We'd have done a great disservice to the whole astronomy community. We'd have screwed up the universal measurements.
Thank God they don't rely on us anymore, Colin, not you and I. Even though they've been up all night, everyone is still basking in the glow of a successful transit.
We are happy that we could do it, because this morning it didn't look as if it would be possible. So I think it was worth coming here with all the equipment.
Oh, definitely.
And I think we're quite happy.
Yes. It was very rewarding that the sun finally shone for us at the end after a long night with clouds passing in, and it was fantastic.
The Venus Twilight team, though, are still hard at work.
This is the edge of the sun, which is perfectly covered by the occulting cone, which is designed for that, actually.
Right.
It's off-centered, it's not in the optical axis of the telescope. This is why this is what allows us to center on Venus and not on the sun. And so it's probably there, acquiring and being written in the form of a file, and this will be analyzed later.
All right, get the data first, do the work later.
Absolutely.
The good news is that Thomas saw the Aureole, that beautiful faint arc of light hanging in space. Australia too got this lovely view, although we still haven't heard from Ulaanbaatar and their elephant. Pete also managed to get a glimpse of the Aureole, an impressive sight. On our Sky at Night Flickr site, we have lots of lovely images of Venus as it went across the sun. And they really show what a global experience this transit has been, with images from as far afield as the South China Seas and Argentina, and even some nice ones from the rather cloud-ridden UK. Our spacecraft above the clouds also got some great images and movies showing Venus flying across the sun, this one from the Solar Dynamic Observatory. A very special event, finished in the blink of an eye. Well, the transit's over in a brilliant blue sky, and I'm feeling a little odd right now. I've always known there'd be a transit of Venus in 2012, and now it's over, and I'll never see another one. That feels pretty strange. On the other hand, we came somewhere spectacular with some remarkable people, and we saw an amazing sight. That feels pretty special.
What a magnificent sight. And I do hope you saw the transit of Venus. If not, look on the Sky at Night website. When I come back next month, we'll be talking about small amateur observatories. Until then, good night.